Yeah, welcome back, Synchronauts. If you've used Windows, you're probably familiar with Minesweeper, this game. This is the Windows XP version. There's different looks and feels and even grid sizes depending on which version you're using. This is the beginner grid. Was this a 9x9, I think? And if you've never seen this game, it's kind of how you play it. Your first uncovering of a mine is always safe, but then you've got to identify where the mines are and uncover the safe cells. Or not, really, you have to either flag them or, uncover them. But this is a popular game. It's pretty old now. There's a long history of games like this, but this really is kind of tied to the history of Windows and Microsoft. So I was reading this programming book called Cracking the Coding Interview by Gail Lackman McDowell. It's a very good book. And in it recommends implementing this game. Not necessarily for Windows or even graphically, but just implementing the algorithms, because there's a couple of interesting algorithms that are part of this gameplay. And, when I first read that, I'm like, oh yeah, I could do that, like as a BBS store. I did do a little research, and I was surprised how many people still play this game. Like, there's this whole website, there's actually probably more than one, but looks like the most official, minesweeper.info. And there's a number of clones. So on this official Minesweeper wiki, you have other versions of the games. So I was surprised to find that there are existing BBS store versions of Minesweeper, clones of Minesweeper. I didn't actually install or play any of these. I probably will eventually, but of course, as the programming challenge, I needed to implement it myself from scratch, and I didn't really want to be influenced by these other implementations, so I started just from my own kind of idea of what it might look like. Obviously, being text mode and limited to ANSI and 16 colors, and you're not going to very closely replicate this, but I really wanted the gameplay to be very much the same. Anyway, so I'll demonstrate what the door looks like right now. This is actually a development version I'll be showing you. I haven't released yet. Oh, look, a couple people running the JavaScript version of Lord. That's from Deuce, and relatively new. So here we are, Synchronet Minesweeper and ANSI 80x25. This is the easiest level, or the equivalent of beginner level, I guess, in the Windows version. You'll notice that it says 1.00, and I'll get into explaining why that is, but basically it's level 1. It's the easiest level. And there's a help command option, so H for help, and it'll go through and explain everything to you, but I'll just explain it to you in this video, since I'm talking to you anyway. So if you have a capable terminal, you can move around this cursor or selector using the arrow keys. If you want to move diagonally, or you don't like your arrow keys, you can use the numlock. So if you put numlock on, then you can use the numpad, and then you can move diagonally like this if that's important to you. I just stick with the arrow keys. Home and end, move to the beginning and end of the line. Page down and end will move to the top and bottom rows. And let me see, what else do we have? I think there's a middle, move to the middle. Is it? Oh, 5. There we go, 5 will take you to the middle. So the middle key on the numpad. And if you don't like that selector, you can go through some options and change it to other patterns if you like. No selector here, if you just like the highlighter, I guess. So how you play the game is you uncover. So there's a counter. You have a maximum amount of time. The default 60 minutes. That should be plenty. For really all but the hardest levels, 60 minutes should be plenty, but sysop could reduce that maximum time if he likes, he or she. So the concept of the game is you're digging up squares on this minefield, and you're trying not to uncover a mine, or it will detonate and explode and kill everybody. So your command keys initially, you got to dig up a square, any square. Your first square is guaranteed to be safe. And you'll notice that it has a number here. It's the same concept as the Windows version. That tells you how many mines are in the surrounding cells or blocks. So you see there's 8 squares or cells surrounding this number 1. So one of those is a bomb or a mine. We don't know which one. And you notice it's highlighting the surrounding areas. That's actually a feature in the Windows version of Minesweeper as well. A lot of people don't know, but if you middle click, it shows you the surrounding areas of like here's a 1, and it doesn't uncover it. Like you don't know what's actually in there. Like you don't see the bomb, for example, here, but it's just showing you the actual surrounding areas in case you can't visualize it in your mind. And I've done the same here by highlighting. If you don't like that feature, it's tab to turn it off, and tab toggle on and off. So that's telling us there's 1 bomb in that area. Don't know which one, so rather than guess, I'm going to move somewhere else. That tells me there's 2 around there. Oh, there we go. So if you uncover an empty cell, and it'll do this flood fill algorithm to clear out all the adjacent empty cells as well. And then you'll hit edges, these sort of walls, and it gives you numbers telling you that there's bombs near there. So like for example, if I select this cell, I know there's 1 bomb in the surrounding areas. There's only 1 cell that has not been uncovered. This is an uncovered cell. This is an uncovered cell. These have been uncovered and they're empty. So that one right here in the upper right, that must be a bomb. So you flag it with F, and you actually have a couple of options. You can either flag it with an F to tell you that you indicate to yourself that you think that's a bomb, or you can hit it again and make it a question mark, meaning you're not sure if it's a bomb. In this case, we are sure. And if you hit it again, it just turns it back to a regular uncovered cell. So it's a 3-way toggle. Anyhow, we know that is a bomb, and so this one must not be a bomb, because if you select this cell, it says there's 1 bomb around it in the surrounding cells. That F tells us that that's a bomb, so that this other cell cannot be a bomb, or else that would have to be a 2 here, and this would be a 2 as well, and they're not. So I can just hit D for dig up, or hit spacebar, and either one, D or spacebar, does the same thing, and it reveals what's there, and it's a safe cell. So corners are helpful. Like here, I go to this 1, and it tells me there's 1 surrounding it, one bomb, 1 mine. This must be it. And now I'm going to show you something called cording. If you have the correct number of flagged cells surrounding a numbered cell, so like here I have a 1 in this cell, and that one of the surrounding cells is flagged, that tells me that I have the correct number flagged. Now I have the option of what they call cording, meaning I can uncover all these surrounding cells that are not already uncovered with 1 key. It's a time-saving feature called cording. I'll show you how that works in the Windows version real quick here. So in the Windows version, if I like flag right here, I'm just guessing, and then I middle click on this 1, it's going to do a cord, and it's going to uncover all the cells around it. Now, if I didn't guess correctly, I'm going to die. And I didn't guess correctly, so I died. So that's not normally how to use cording. Use cording normally when you're absolutely sure. So like here's an example. I am positive that this cell contains a bomb, but I can't cord yet because these ones are already uncovered all around. This 2 means there has to be 2 mines around it, but there's only 1 flag. So I can't, if I middle click there, it doesn't do anything. So if I flag this one, now middle clicking does nothing because they're already flagged. So I can't really use a cord there, but here's an example. I can flag here, and now I can cord this 1. I'm just going to middle click right here on this 1, and it's going to automatically uncover these ones down here. It's just a time-saving feature called cording. If you have the cell incorrectly flagged, it's going to uncover a mine which is going to detonate and kill you, and game over. So you don't want to do that. So anyway, back to the Synchronet Minesweeper here. I have 1 cell flagged. It's a 1 here, so I'm going to use cording, and you can see the cording option went away. It only appears when it's valid option. So like here, I flag, and now I can cord. Okay, and also you see the number of remaining mines is going down every time I add a flag. Like here, see the number of mines going down. That doesn't mean that I've correctly flagged those. It just tells me that number of mines are unaccounted for. And so here again I can chord, here I can flag, I'm going to chord again, chord again. These beginning levels are really easy. So 2, so I know this is a mine, right? Because there's 2 surrounding and there was only one more uncovered cell. So I'm going to go here and chord, go here and chord. And I'm just moving around and hitting C, really. It's pretty easy once you kind of learn the chording option. There's 2 cells here, so that I know that one must be a bomb. 2 again, I can chord. 1, or I'm sorry, 2, so that's a bomb. Chord. Go here. So it's pretty obvious, right, which cell has the bomb, right? There's 2. There's only one that's uncovered, this highlighted one here, so that's a bomb. So here, 2 again. There's only one uncovered, so that must be a bomb. 3, same thing. 2, well, 2 are already flagged as bombs, so the remaining one must not be a bomb. So again, C, chord, and game over, but I won. So yay! And my time there is terrible. If you look at the winners, you can look at winners of different difficulty levels. So level 1, and you see that the times are, here's the current winners, mostly my brother and I, Dr. Seuss. And they're all like far less than a minute to clear this level, which is 100 cells, 10 by 10. So pretty easy. At this level, it's all about how quickly you can do it. And so if you don't flag and you don't use chording, maybe you can do it even faster than any of those scores. The guys that do it like international competitions, just the Windows version, they're incredible. They clear the beginner map in like in 10 seconds. So here, if you notice when you start a new game, it'll ask you what difficulty level. So that was difficulty level 1. If I go 2, it's getting bigger. And you notice the level said 2.0 here. So just quickly demonstrating, what this looks like when you start uncovering. Yeah, there's a lot more cells. It gets a little bit harder. It's going to take longer to complete. You also have more opportunities to have to guess where it's not clear which cell contains the bomb. So I'm just going to go ahead and start a new game here. So we'll say, new game, level 3. Okay, so it's a 3.0, but it does look like the bottom of the game is chopped off. It's not actually. It's just not drawing that bottom border, but it does all fit on the terminal, so this is a 3.0 level. Let's say level 4. Oh, look, it's not actually a 4.0 level. It's 3.94. And the reason is because this terminal, this is an 80 by 25 sync term window here, could not contain the ideal level 4 map, which I think is a 25 by 25 or 20 by 20, I forget the grid size. So it's close, it's 3.94. If you have a bigger terminal, then you can fit that many cells. But the difficulty level is really based on the mine density. And then a level 5, I'm not going to be able to accommodate, again, because I'm 80 by 25 here. And this is kind of explained in the help. When you get down here to difficulty levels, it talks about the target grid and then how the actual difficulty levels are computed. So when you look at winners for level 4, let's say, you see there's a 3.96 and a 3.75. There actually have not been any level 5 winners yet. It gets pretty hard when you have that many cells. Okay, so let me demonstrate with a bigger terminal so you can kind of see what that might look like if you actually use a wider terminal. So in this case, I'm using a 132 wide by 51 rows. Again, sync term, but you could be using some other terminal program. And it centers the board on the middle of the terminal, regardless of the size. So here we are, a full level 5. So that's why it's 5.00. You're getting the ideal size, and then level 4 is a full 4.0 because our terminal is bigger. So it's just kind of a way of making sure that the sorting of the top scorers is fair, that somebody isn't getting an advantage just because they're using a tiny terminal. If you're using like a 40 column terminal, you're just not going to be able to play these more difficult levels at all, really. So I could demonstrate that, but I kind of want to demonstrate like the dying POW. Okay, so I have a random set of graphics there, and then a frowny face. So that kind of mimics a bit what happens in the Windows version when you die. You get a frowny face icon there. And then there's a log, detailed log of all the wins and losses. Mostly here, this is just me testing stuff. And if you don't want to go through the whole log, you can just hit N or Q, the pause prompt. And that's pretty much the game. I think I demonstrated question marks, right? Let me do that real quick. Just if you really want to get tips on how to just generally play Minesweeper, there's a lot of YouTube videos on it that are pretty good tutorials, and they're great players. I'm no great Minesweeper player, but I think I've got the general strategies down. So let's say you weren't sure, like you said, okay, the ambiguity is really, you need a more difficult, a higher difficulty level to really get ambiguities. So we know that's, so, okay, let's just say, for example, I know that one of those three highlighted cells is a bomb, but I don't know which, and I want to remember that one of those three, so I can make them a question mark, and it's just a little note to myself. One of those three. So then if I go over to this 2 here, and I go, well, I know one of those three is a bomb, and this 2 tells me that this one must be a bomb, so that means that these 2 must not be a bomb, because otherwise this is only a 2, it had to be a higher number. So I can safely uncover these with the space bar, for example, and then I can safely flag that one. So that's kind of what the question mark is used for. It's just a little visual cue to yourself that you're not sure, you know, here's a set of cells that may or may not be bombs, and I want to remember exactly which ones I'm thinking about, and be able to move the selector around the board, you know, without affecting my memory of which cells I was trying to recall. So that's what that question mark is all about. And when you uncover a bomb, obviously, oh, POW again. So this, I do have a random set of explosion graphics, but I seem to have gotten POW a couple times. POW! Yeah, we're just getting POW every time. That might just be bad luck. Let me see here. Boom! Okay. Anyway, there's a few different expressions of death there, but yeah. So it's written in JavaScript. I'll go ahead and show you the source code here. I could have written in C, but you know, you get a lot of things cheap or for free with JavaScript and Synchronet, so just kind of keeping with the times. And you know, there's no obvious performance penalties or anything, and it actually made writing the game pretty easy. So the interesting algorithms I was referring to earlier, the random placement of mines, how you might first think of accomplishing this is for the number of mines that you want to place, in this case game.mines, you might just say, okay, you know, pick a random number between 0 and the maximum board grid size and put a mine there if there isn't one already there. And that's fine, but the problem is, what if there's a mine already there? Then you have to kind of say, okay, do it again. Give me another random number. And if you have a high mine density, then you might frequently get this collision where you're seeing, you know, you're randomly picking a cell, but it already has a mine. So then you have to do it again. You really probably would never notice that in the gameplay, but a more ideal or optimal algorithm is instead to place the mines into, say, the first N board cells, like I'm doing here, going through game.mines and just putting the mines sequentially in the upper left most portion of the board, and then move them to a random cell. So that way you're guaranteeing, because you're moving, you're swapping actually, that it doesn't matter if there's a mine already there. Well, you're swapping too. So at most times you're never going to have a collision. Basically, it doesn't matter if there's already a mine there. You're just going to be swapping, you know, between a mine and a mine. No change, and then you move on. So there's no potential for a high number of random number calls. You're only, if you're going to place 10 mines, you're going to get 10 random numbers, and that's your placement of your mine. So it's a more ideal algorithm. Poorly explained. Okay, and then The next algorithm is that sort of flood fill algorithm where it's going to find all the adjacent safe or empty cells. So I have this uncover function in here, right? I think right here, uncover cell, and then uncover. So you can do this iteratively or recursively. I just chose to do it recursively. So you can see this uncover function calls uncover. And it does that as long as there are mines that are adjacent that are uncovered. And then when it does uncover it, it flags it as uncovered, so it won't try to uncover it again and have like an infinite loop. So those are really the two interesting algorithms programmatically, and it's not too complicated, but still, these are good things to know for like programming interviews. They might ask you how like you would implement like a paint fill algorithm like in a paint program, like a graphical, kind of like Microsoft Paint. How you would actually implement like that paint can control where you fill an existing contiguous color range with a new color. And that's kind of the same algorithm. You just keep looking for adjacent cells, and you're doing what's called a depth first search. That's what the algorithm is called. And that's what that is. And I'm doing it recursively, but again, this could have been done iteratively where it just keeps track of all the visited cells and be sure not to revisit them. And then the rest of the code, if you want to look at it, it's in CVS, and I didn't really use a whole lot of helper libraries. I used the graphics library a little bit for like those little splash images, like the smiley faces and such. Using the console object in Synchronet, obviously, for the ANSI and PETSCI cursor positioning stuff, color coding, screen clearing, all that, those kinds of functions. But there's also, this shares the winners. So when somebody wins a game on your BBS, it shares the winners through the sync data subboard. If you have that, like on DovNet or FidoNet, it automatically discovers the sync data subboard and then shares the winners. So if you are on the BBS and you list the winners, so like here's a list of top winners, and you can see there's a couple of wins from Deuce on his BBS SyncNix here, and those can be FidoNet addresses or QWK networking addresses. So it's pulling those automatically out of the message base. You don't have to like run an import or export event or anything. The configuration is really simple as well, but I'll show you a screenshot from SCFG how to do that. So this is what the configuration looks like. Most of the options are no, none, disabled, whatever. There is a readme.txt as well in this extern Minesweeper directory, which tells you how to install it as well. And if you want a like logon event that displays the top winners, that's kind of like how this is done. Just calls the same command line but adds the word winners to it. And you control the number of winners that are displayed. Anyway, it's been a fun project, and hopefully we get some real good Minesweeper players in there to kick our butts and teach us a lesson about how you really play this game. So, till next time, take care.